So in this video, I'm going to teach you how to rationalize an expression. So what I mean by that is that in math, it's actually not allowed to ever have an expression where you have something irrational in the denominator. So if you can remember back from when you first learned about types of numbers, things that are irrational, a very famous example is pi, because pi's digits go on forever, but they have no pattern. And it means you would never be able to, if you think about your calculator, math racket. Other examples that are really easy irrational numbers is something rad 2. So since 2 is not a perfect square, if you type that into your calculator, again, you're going to get some nasty decimal, and it won't math frac because there's no pattern to the numbers. So this would work for any number that's not a perfect square. Another newer thing that we just learned about that's also irrational is something like I, because I, as we know, is really square root of -1, and again, -1 is not a perfect square, so this also falls into that category of something that can't be left in the bottom of a fraction. So here we have a radical 6 on the bottom and an I on the bottom. So I need to do something to this whole expression to make it so that there's no longer an irrational in the bottom. So when I have something like radical 6, it's actually really easy. I can just multiply by another radical 6, and if I do it on the bottom, I have to do it on the top as well. This is helpful because now radical 6 times radical 6 gives me plain old 6. We've been talking about that a lot, that a radical times itself just knocks the square root out. And on the top, 3 times radical 6 is just 3 rad 6. So I have just rationalized this expression. I, however, can simplify because 3 divided by 6 does reduce. So this is really, you can either write 1 rad 6 or just rad 6 over 2. So all I did was divide both the 3 and the 6 by 3. Okay, so if I have something with an I in the bottom, it's very similar. If I multiply by I, I'm going to make that irrational expression go away. So 5 times I gives me 5i. If you remember from the powers of I times I is I squared, but we can do better than that. If you type that into your calculator, it might ring a bell that I squared is actually -1. So if I have 5i divided by -1, I've rationalized it, but again, I can make that a little simpler. This is just negative 5i. So that's the rationalized version of 5 over I. Okay, so those are some simple examples of rationalizing. Here's some expressions that are a little bit more complicated. So now I still have those irrational things in the bottom of my fractions, but they also have stuff attached to them. So I can't do as simple of an approach as I did on those other examples. Here I need something called the conjugate. So a conjugate, which is a pretty important word we talk about a lot this year, is an expression that has the opposite sign in the middle. So the conjugate of 3 minus 2i is 3 plus 2i. You're going to see in a moment that if I multiply these together, I'm going to get rid of the thing that was irrational. If I do it on the bottom, I have to do it on the top. So I'm multiplying 5 by 3 plus 2i. I don't really need this fraction bar. That's not necessary. Okay, so you can do this by hand if you'd like to actually do the distributing. However, as we've been talking about in class, now that your calculator is in A plus BI mode, you can actually type all of this into your calculator. So if you do 5 plus 2i in your calculator, you get 15 plus 10i. If you multiply 3 minus 2i and 3 plus 2i, you should just get plain old 13. You want to just make sure you put those parentheses around both expressions. That is one thing that's important in the calculator. Since 15, 10, and 13 don't have anything in common, I am done. That can't be simplified. Okay, so this next example is very similar. I can use the conjugate of what's in the bottom, that is, to get rid of the irrational number. So I'm going to use 2 minus rad 5 on the top and bottom. Here, unfortunately, we can't use our calculator to help us out as much because if you type radical 5s in your calculator, they come out as nasty decimals. I's are nice because they just stay as i's. So I'm going to actually have to double distribute on the top and the bottom. Okay, so 2 times 2 gives me 4. 2 times negative radical 5 gives me a negative 2 rad 5. Then I have negative rad 5 times 2, so I actually have another negative 2 rad 5. And then finally, negative times negative is going to give me a positive, and we were talking about how a radical times itself just really ends up dropping out that radical, so that's just a positive 5. On the bottom, same idea. You're going to get very similar things. 2 times 2 gives you, again, that 4. 2 times negative rad 5 is negative 2 rad 5. But this next one is positive radical 5 times 2, so that one should be positive. And since these signs are plus and minus, our last number is going to be negative, and we have that rad 5 times rad 5 again. That just gives you 5. Okay, so now we have to clean this whole thing up. So one thing that's nice is that on the bottom, we have a negative 2 rad 5 and a positive 2 rad 5. Those are the same expression but with opposite signs, so those are gone. On the top, I can combine like terms. So the 4 and the 5 can be combined to make 9, and negative 2 rad 5 and negative 2 rad 5 are like terms. That becomes negative 4 radical 5. On the bottom, all I'm left with is 4 minus 5, which is just negative 1. So while that looked really messy for a minute there, once you combine everything, it comes out a lot nicer. Again, I could leave this like this or just actually divide everybody by negative 1, which would make negative 9 plus 4 radical 5 as my final simplified answer. So those are examples of rationalizing using the conjugate.